All right, so in our last video, we created a student class, which is our blueprint, student.cs. And then we created this student app, not necessarily in that order. And this is where our main method resides. And in our main method, then we created two students from our class. And we used the dot notation to access those fields. This is kind of confusing to see, to have to toggle back and forth, so I'm going to make this a little bit easier on myself. I'm going to click on this student.cs tab, hold down the mouse, and drag the window. In the middle of my screen here, you can see that there's different orientations for this window that I can choose from, so I'm going to choose the one on the far right in order to make these windows side by side. It'll make it a little bit easier for me to see. So you can see my different choices, and if I choose this one on the right, that's side by side, and let go of my mouse, now I can see these two side by side. That's a little bit easier for me to deal with since they are kind of related to each other. I'm using this class for things. All right, so that being said, what I'd like to do next is create, these are states. This is a value that a student can have. In other words, a student can have a name, a student can have a last name, and so forth. But there's also methods that we're going to want to produce per each student, so that way we can calculate averages or print out their name, or things that are specific to an instance of the student. In other words, Lilo might be running a method that does the same thing as Indy, but the output's going to be different. In other words, if I wanted to print Lilo's name from a method, I want it to print Lilo. I want it to be specific to Lilo's instance of the student as opposed to Indy's. So let me just make these methods, and hopefully this will make more sense as I do it. So we're going to create what's called an instance. Let me just type this out for you. An instance method. In other words, this method is going to be smart enough to know which object is calling me. It belongs to the instance of the object. Remember we instantiated an object, so this is an instance, one instance of a student object. Indy's a second instance of the student object. And if we call the method, it'll be specific to that student. Let me demonstrate. So let's create a method. You already know all about methods, but we're going to make this public, again, because I want this method to be available to whoever uses this class. It's not going to return anything, so we'll use void, and I'll call this print name. Now remember, our method should be descriptive of what the method is doing. It should be a Pascal case capital, so that's what I'll do here. And I'm not going to receive any information. Okay, so I'm not receiving any kinds of parameters, but I can still write line. Let me just type this out, and there's going to be several things we're going to have to fix here. Hello. Put a placeholder for a variable, and f name is, I'm just going to have it print out that f name. All right. Notice then, in order to utilize WriteLine on this class, I still needed to include the static. If I can't depend on the student app, because the student app might not be the actual application that utilizes this class, so I need to be aware of that. So I have to have the static system console on there to be able to use the WriteLine by itself. Okay, fantastic. So what's going to happen then if I run, let's go back to student one. Student one now also not only has these field names, but it also has a method that knows what instance is using it. In other words, if I do student one and I call the method print name, there it is on my little IntelliSense. I hit tab, and I don't have to send it any information. It says I don't have to send anything. And I do the same thing for student two dot print name. It's not sending any information over. Now if I run this, each instance of the method that runs knows what object it belongs to, and therefore will print out its instance of that data. Let's just run it and see. So now I should see two print lines, one that has Lilo's name and one that has Indy's name. So Control F5, and let's see if that in fact happens. Hello Lilo, hello Indy. So hopefully that demonstrates an instance method. In other words, since I'm creating this method inside of this blueprint, therefore, when student one print name runs, it's its own copy, its own blueprint, its own stamp, if you will, that has its own first name, its own last name, its own method that's called print name, and therefore its own name. And so therefore I can use that same method for whichever object utilizes it, and it knows who I am. Whoever I called, whatever instance of student used me is the one that gets this value. Okay, so that's what instant methods are. Let me add to the pot here. I'm going to add another instance method. I'm also going to call this print name. And in this method, I'm going to receive a string called that I'm going to call greeting. It's a local variable, so it's going to be lowercase. Okay, let me just finish this out and then answer hopefully this question that's burning in your head. So I'm going to put a placeholder for 0 and then an exclamation point. I guess no, exclamation after. So let me just finish this out and then hopefully you'll see where I'm going. So for the first place, I'm going to put greeting, and in the second place, I'm going to put fname. All right, so we have here what we call a problem, usually, because we have a method that has the same name. Can you do that? Ah, there's the question. So now we've got an instance method. They're still both instant methods, but they're also, I'll just write it in here so we have it, overloaded methods. Excuse me. And what an overload method means is we have a single method that has the same name, but technically the compiler is going to see it as different methods depending on what parameters this method, this signature, is expecting to receive, what information expecting to receive. In other words, these technically are different because this print name method is expecting to receive a string that it's going to call greeting. This particular method is not receiving any parameters. So if I were to run, let's see, we'll do two separate ones. So if I have student one print name and I don't send any data over, the compiler is going to say, let's see, which print name should I run? Well, they're not sending any data. This method isn't wanting any data, so they must mean this version. If we instead send over a string, which I'm thinking is greeting, so we'll say hello. Okay, so when this method runs, the compiler is going to look for print name. Oh, there's nothing. No, there's some data being sent, so I'm not going to run this version. And then this one, oh wait, yeah, it's sending me over a string, so this is expecting to receive a string, and so this method is going to run. Whew, that's a lot. Let's go ahead and run the debugger, run this through debug and watch it happen. So debug, start debugging F5, and hopefully we'll see this in motion. All right, so we're stopped here. We're not sending any data over. Let's just see, student one has a name, F name, student one has an L name, so that all looks good. We didn't give it any scores, so and student two hasn't been defined yet, so we're looking good so far. So now run print name. So we're just going to ask the compiler to step into that. And it noticed right off the bat, you can see this little arrow says, oh, this is the print name I'm supposed to run. And so it should then write line. Now again, how does it know F name? Because you notice I put my cursor over it. It gives me the value of F name because I am running the instance of student one. Instance of student one says, oh, student one's F name is Lilo. So that's what's going to be displayed here on our console. So let's run that out. And then student two, we're creating a new object for student two. Student two has a F name of Indy. Let's just watch that happen. Yep. F name, it has student two has an L name of Jones. That's fantastic. And now print name is actually sending over a string. And so this method is running. The compiler says, oh, this must be the print name you were referring to because it's expecting a string. You sent me a string. And so now this print should run. So that should look familiar. Greeting is what is the value that got sent over. And then fname then is the name of, oh, here's the greeting here. And fname is the name of this particular instance, which happens to be Indy. So that's why we call these instance methods. And then it should finish out and didn't display our console. But if we run our console, debug, start without debugging, and this time actually see it. Uh-oh, looks like I have a problem with my, let's fix that. Right line, yep, I sure do. Can you see it? Yep, okay. Probably should have noticed that in the debugger, but there we go. All right, so now let's run our tools, debug, oops, start without debugging, and there we go. So instance methods and overloaded methods were covered in this particular video.